So welcome everyone. It's always good to take a map with you when you're going somewhere new, especially when the cell reception means you can't use your phone, and there are very, very few signposts. And a true explorer, of course, when going somewhere new, will have to draw their own maps. And you can't get much more new and frontier like than a trip to Mars. So we need a good map of Mars if we're going to explore this planet. Good afternoon, good evening, everybody. My name is Simon Steele. I'm the Senior Director of Education Outreach at the SETI Institute. And I'm very happy to talk today with Dr. Henrik Hargitay. He's a professor of geology at Eötvös Loránd University in Hungary, and also a SETI Institute affiliate. And Henrik has developed and published this amazing atlas of Mars. And we're going to talk a bit about Mars. We're going to talk a bit about the atlas and how you actually make an atlas. So I'd like to start off, Henrik, just tell us a little bit about what your motivation was of putting an atlas together. And you're muted, unfortunately.
Hi, good evening. So it started as a scientific project to help scientists in mapping Mars and finding landing sites. When I worked at NASA a few years ago, I collected different layers, different data sets, catalogs of different features of Mars, surface features, landforms, global catalogs. And as I overlaid layer by layer, a new picture emerged of Mars, a more complex picture, a sort of synthesis of what we know of the surface of Mars, not just the topography, not just the geologic units, but a complex picture that you usually see in physical geographic atlases, school atlases actually, what I remember from my childhood or my student years. When I turned the pages of school atlases, that's what I wanted to sort of replicate for Mars. And in the last decade, we collected enough data and the researchers mapped Mars in such a detail that this is just the time that we are able to make it.
Okay. Well, we're going to explore the atlas in a second and explore indeed Mars, and you're going to have this little guided tour over this amazing planet. I'd like to welcome everybody who's tuning in. Please do let us know where you're tuning in from around the world. We'll give you a shout out. And of course, we'd love you to ask questions about Mars or about atlases, cartography, anything that you care to ask, and we'll put those questions to Henrik as we work our way through. We'll also point out that this is a free service we're offering to you. The SETI Institute, as you know, is a non-profit organization, and we do rely on donations. So do please feel free to offer any donations you have to keep this service free, and us keep on inviting fabulous speakers to talk about the universe. So Henrik, when did you start this project, and how do you go about the initial stages of mapping or creating a map of a planet?
Well, it started 20 years ago when I was a student. I had my first internship at the LPI. I'm at Io at that time, but I moved to Mars when I got back to Hungary. I made the first map of Mars in 2001. That was an outreach map, a wall map for students, basically in 5 Central and Eastern European languages. That was a project from Moscow, actually, a multilingual terrestrial planets series, and the first one was on Mars. And then when I got to NASA, I started to make it professionally. And as I mentioned, I collected these different layers of features of Mars, and I started to explore what you see in the background, the color ramp of Mars. What should be? I didn't really like the rainbow colors that you usually see in topographic map of Mars. So I tried to develop my own colors for Mars that's closer to our visual experience of Mars, but also shows the topography in enough detail and do not use greens and blues because that has different connotations. So I eventually made this yellowish brownish thing some 5 or 6 years ago, and this was further developed in the atlas. I use a little bit different colors now. So I of course I participated in a few Mars Society simulations in Utah in the Mars Desert Research Station, and that's when you really realize that when you got to the field, you do need a map. Of course, I don't think that the Martian astronauts will hold this map in their hands, and it will be digital. But still on Earth, and especially for students, I'm still belong to the old generation who used to hold physical objects in their hands. And turning the pages of this atlas is such a good feeling, and you can browse actually the landforms, the Martian map. It's a completely different experience from looking at the screen and browsing the same thing on the screen. It's different. So it was designed, this map was designed to be printed. That's really something unusual for planetary science in 2020 to print out a map. Of course, scientists don't use printed maps because we use data sets and GIS. But for the general public, I think, and I'm part of the general public in that sense that I love browsing paper maps. So I look at different things. I discover different things because I have so time passes by differently when you hold the paper object in your hands.
Yes, I agree, but maybe that's because we're similar ages. It's interesting you chose the color scheme, and we'll look back at that, because maps don't generally reflect the color of the real thing that they are. We use, and in astronomy, we use the term false color all the time, which is assigning colors to surfaces that tell us a little bit more information about that surface. A common one that everyone knows, of course, are weather maps, where the hot regions are red and cold regions are blue. That doesn't mean that physically the ground has turned red or the ground has turned blue, but assigning these colors, and here we are, assigning these colors to these regions allow us to draw out features that we want to emphasize. But you decided to go for Mars in maybe slightly more realistic color. Maybe tell us a little bit about Mars. Let's talk a little bit about Mars itself. So when we dive into the atlas, it'll the viewers will have a more of a concept of what you're trying to achieve there. Tell us a little about Mars and its color.
So that's the new version with grays instead of the yellow ones, but still it doesn't have an Earth-like feeling, Earth map-like feeling. It has the feeling that it's an alien world. It's an alien topography. And my basic question about Mars is how alien it is, or how much does it tell about planetary evolution? How much does it tell about our Earth, of course, about how normal Earth is amongst the billions of planets? And Mars is when you want to know, it's about personality. Planetary personality. If you want to know more about yourself, of course you can start discovering yourself, your interior mental cognitive processes, but the best way to discover yourself is to compare yourself to other people, what other people do. And this is how the norm comes into this picture, because what's normal and what's not normal, you will learn from the others, from the many other people. And similarly, turning psychology into geology in this case, a little bit wide turn, I know, but how normal, how average our planet is, that's, I think, a very basic question of geology and planetary science, because we don't know too much about other planetary bodies. We know some 20-something planetary body in a solar system, but in the habitable zone, not too many. Yeah. So Mars is the closest one. So if you study Mars, you will at least have two examples of Earth-like planets, and you will know if Earth is exceptional or unique or just an average planet. And what you see on this map is that Mars is really, really different from Earth. Although the pictures sent back from the rovers look, the pictures look familiar for us because Earth deserts looks something like Mars deserts, but that's just the surface. That's really just the surface. The temperature is completely different, and the geology and the age is completely different. The surface of Mars is 3 to 4 billion years old. There are not such surfaces on the Earth. It's a few million maximum, few 100 million maybe. So it's very different. And this map and the valley networks and outflow channels all show that we recognize these landforms as channels or paleo channels or volcanoes, there, the large volcanoes, but those couldn't be made on Earth because of the time that passed on Mars without too much changes on the surface, or the geology, the lack of plate tectonics that recycles the crust on Earth, and which is not happening on Mars. It's a really old planet. Although the age, of course, is the same as almost the same as Earth. All the planets are of the same age, but the surface of Mars is much older.
It's sort of been frozen in time, hasn't it? As you say, the Earth's surface is constantly reworked. Most of it's covered in water, which of course wipes things out. And then any cratering that happens is either going to be sort of destroyed by plate tectonics or forests or things like that. And the weather from the very relatively dense atmosphere that we have. Yeah. So we've got a almost like a fossil world that we can study. And just before we go any further, I just want to call out, we got lots of people tuning in from all over the world. Long Beach, California, Utah, Brooklyn, Cork in Ireland, Paraguay, Spain, Germany, Bournemouth in the UK, Seattle, New Jersey, San Francisco, Transylvania, Romania. So welcome everybody, and thank you. We've got some questions coming in, and I'll read out some more in a little bit more. Henrik, maybe it's time to dive into to have a look at a bit of Mars. And once we do that, just a question: what is the biggest challenge to doing creating a map from scratch, if you like? What did you find the toughest part of it was?
The first one, collecting the information, collecting the data. And I did not create these data sets. I used many other scientists' databases and catalogs that had been made in a period of a decade at least. So I rely on other scientists' works. I couldn't make this atlas myself alone. Of course, not speaking of the spacecraft missions and the images. So I just, as Paris as the geographer of the Little Prince, I just collected the data that had been made by other people. But that's what geographers do, actually. They synthesize. So the complex picture shown here are usually not appearing in geologic papers. They just focus on one issue, one type of process or one type of landform. That shows Mars in its complexity. So what you see, you mentioned that Mars is frozen, but it's also, so it shows somehow Earth before vegetation. And it was not very long time ago. It was just 500 million years ago. So it's the last portion of terrestrial history that we have vegetation on the surface. So if you look at the dry deserts of Mars or the paleo channels, that's how Earth might have looked like, the continents before vegetation or animals went there. So that's us, and perhaps that. And the other thing with Mars is that we don't see any life there, and probably that's how Earth will look like in 1 billion years time, when luminosity of the sun will be too high. And so Mars shows us the far past of the Earth, and Mars shows us the far future of the Earth, in a way. And the question is how, if there was life, how it disappeared. If there was life, and if there wasn't life, why there wasn't life. So back to the original question with the maps. This is a double spread of the atlas, and it shows the two. Well, it's not the best map to show that. I will show another one, which is the border of the northern part and the southern part. The southern part actually is a trial border, and the volcanic part. So these are the three different terrains of Mars. One is the southern highlands, which are the cratered ones, which are the old ones. And there are these smooth areas, which are covered with, here they are, covered with lava. Not very old, but also not very fresh lavas. And the northern part is the lowlands, with a very few craters, young craters on the surface, and that's a plain. And what kind of plain? Is it sedimentary, or is it volcanic, or both? Probably both. It's still a question. That's might be the place of the ocean a very long time ago, but who knows? If you go to the southern highlands, then this basin here is a large crater. That's the largest crater on Mars, Hellas Planitia, which, if you go closer, you see that's a huge basin, and there are rivers flowing into that basin, lots of rivers, and the blues are glacier features. So there were a multitude of processes operating, perhaps at the same time. There are volcanoes here, outflow channels, and normal river channels, and glacier features, and this large basin that might have been filled with water at one time.
Could you go back to the previous image of the globe? And this shows something very interesting about the structure of Mars, and these are these are two hemispheres here, aren't they? And you've got the southern hemisphere there that is sort of brown and covered in craters, and the northern hemisphere, which looks much smoother, except for this Hellas Planitia, which is, as you say, an impact crater, a giant sort of depression made by a huge impact. But there's this shows immediately the distinction between the northern and southern hemispheres of Mars.
The other thing is, again, let's compare it to Earth. What kind of features are we used to see in terrestrial experience? Mountains, for example. What kind of mountains are on Earth? Usually, these are mountains that have been created by an organic processes, which means that when two plates go together and compress, and the result is a mountain. Is there anything like this on Mars? There isn't. So all the mountains that we are used to see on Earth are completely absent on Mars. The mountains of Mars are either volcanoes, volcanic shield volcanoes, basaltic volcanoes, or the rings of craters, crater rings. But there are no mountains in the terrestrial sense, except for perhaps this one, but this is a very usual one. And the last one in this is also that large crack, might be tectonic, is a very unusual feature. But still, it's volcanic. It has lots of volcanism here. Go ahead.
No, I'm saying that there's a couple of features that stand out even from this global view, and maybe we can have a look at a close up on in the atlas as well. One is, you mentioned Valles Marinaris, which is this huge rift valley, that's almost the size of North America in terms of width, and incredibly deep. So the Grand Canyon could fit in one of its little tributaries. And with this atlas here, you can see from the color difference, which is false color, of course, because it's all, it's all the same color if you look at the satellite images. But it really draws out the complexity and the location of the Rift Valley, and you can see there's lots of craters scattered around in this particular image. What are the pink areas? You've marked on some features as well, not just naming features, but you've got some other markings on there. What are you pulling out with those features?
Well, the lines are channels or valleys or something in between that might be, well, that's a question. Some of them are tectonic, some of them are lava flows or lava channels, but most of them have been probably made by flowing water, liquid water. At one time, these have been active for a very short time, very long ago. So these are not recent rivers. There are no rivers on Mars. The only rivers in the solar system are on Titan, the moon of Saturn, but not water flowing there, of course. So that's one thing. I wanted to create with the color, I wanted to communicate that these are not rivers like the blue rivers on terrestrial maps, but this is some alien thing, very old one, dry rivers actually, wadis in the terrestrial terminology.
Okay.
The other, if you want to see a lot of them, it's the southern hemisphere, the crater highlands, where it's a very dense network of these valleys. Some of them are not named, others have some name. But that's interesting that there are lots of places on Mars where features has no name at all. So it's still,
there's a naming opportunity for future scientists. So those of you who are interested in going into Martian research,
exactly.
You still have time to have something named after you. That's good. Well, could you bring up an image of one of the lander locations, maybe where Perseverance is at the moment? Because you do have the lander points, don't you, of the rovers and the missions to Mars, which is fabulous. I see, as an Englishman, Beagle 2 over to the right. We'll ignore that one for a little while. But you've got here we got Perseverance and the location of the Perseverance lander right on the boundary here between the rugged highlands and this basin, which may or may not have been an ancient ocean.
Yes, that's part of the northern lowlands. So it might have been inundated by some water at one time, but it's basically covered with lava and volcanic features. Very unusual volcanic rows of cones. It's called thumbprint terrain here in Isidis Planitia. And so that's again a meeting point of three different worlds, different topographies: the southern cratered highlands, the volcanic smooth lava flows and lava fields, and this impact basin, very old impact basin.
Excellent.
So, and that's why it landed here. Of course, Jezero crater is somewhere here, and the delta is there. So there are short rivers here, but it's not the river like here in this in the highlands. It's the very short rivers. It's very unusual river actually, that created that large delta, and that has no connected network. It's just a channel.
Yeah. I have to ask, we're going to turn over to questions now. We've got lots coming in. We've got lots of people again watching in from Louisiana, from Portugal, from Wales. Hi, Steve. I shouldn't call that personal friends, but hi, Steve. Thanks for watching. Calgary, Manchester in the UK, Ohio, South Carolina, and Scotland. I just have to ask one question before we turn. The definition of zero longitude on Mars, who came up with that? And I know there's a bit of a historic wrangling over the zero longitude on Earth. How was it decided on Mars?
That was quite long ago, in the middle of the 18th century, and I have this in a historic map. That was the first map, first map-like map created by the Italian Schiaparelli. But it was here you can see these two figures, Beer and Maedler, German astronomers who first mapped Mars, actually, who first mapped in 1841 the albedo features, the dark spots of Mars, using a telescope. So they decided that there was a small spot, dark spot, that was easy to find. And of course, you could follow the rotation of Mars 24 hours and a half. So they decided that that should be the zero longitude. And later they named the crater in the middle of that crosses the zero longitude Airy, who was the royal astronomer in Greenwich, where, of course, the terrestrial zero longitude goes through.
Yeah.
So it has a very interesting history over history. Many stories are built into the nomenclature, the place names of Mars. Many scientists who observed Mars are there commemorated with names of craters.
Excellent. We've got some great questions coming in. First one is actually about temperatures, and I know you have had a temperature map. What are the temperatures on Mars day and night, and how do they vary between the pole and the equator?
So the poles are very cold, and that shows in Celsius centigrades, minus 131 Celsius degrees are on both poles during the that's winter time, the local winter. In the summertime, it's a little bit warmer, minus 100 Celsius. It's still quite Antarctic. But if you look at that's something new. I created these diagrams for this atlas because that's something you used to see in school atlases again, climate diagrams. So you see the changes from during the year, and you see that the changes are, this is 0 Celsius, that's minus 100, and in the temperate zone where Hungary is, and most of us are. So you see that during the winter time, the maximum temperature is minus 110, the minimum minus 120. So there's no too much change because it's dark, mostly dark. But in the summertime, and it's really, there are 4 seasons in the temperate zone. In the summertime, the maximum goes up to 0 at ground level, which means that when you touch the rocks, then it's 0 degrees hot. But when you go up to 2 meters high, it's minus 30. So there is much higher, somewhat higher change between the ground and a few meters up in the air. But again, the nighttime temperatures are minus 80 to 90 on the same hottest day in the middle of the summer. So the difference is much larger than on Earth. But in the equatorial zone, so in the equatorial zone, all year round it's summer, but still the summer daytime temperatures are above 0, but the summer nighttime temperatures are again minus 100. So the nights are always very cold everywhere on Mars. So
it's interesting. I mean, the days on Mars, the rotation on its axis is similar to the Earth. You know, it's a similar timescale, and the tilt of the axis of Mars again is very similar to the Earth, purely by coincidence. And so you do get the seasons that you get on Earth. I mean, but obviously the big differences there are the complete shift in the temperatures downwards.
Because it's farther away from the sun, so it's colder, but there are no clouds. So because it's always sunny, almost always sunny. And of course, the main reason is that the air is much thinner, and the greenhouse effect is much smaller than on Earth. If you would increase the greenhouse, the change would go down, and there would be more Earth-like conditions.
The atmosphere on Mars, of course, is so tenuous. It's pretty much all CO2, carbon dioxide, but it's the equivalent of the Earth's atmosphere at something like 100,000 feet altitude. So it really is practically nothing there. And and that's what prevents the heat from being locked in. Like some greenhouse effect is good. A lot of it, greenhouse effect is not so good, as we know, and we can talk about Venus in that case.
Sure.
So, question about actually going back to Mars and the history of Mars. You showed this lovely sort of image of the historical side of Mars. And of course, the first images, the first sketches of Mars by Percival Lowell had canals on it, and the implication that there were Martians who were channeling water from the poles down to the dry equator and everything. And of course, that turned out unfortunately not to be true, although we certainly are not threatened by Martian invasion these days, which is probably very good. But there's another question about science fiction, and there'd be more recent science fiction films like The Martian. And what's science fiction got right, and what has it got wrong, if you like, as far as Mars is concerned?
Well, when you visit Mars, when you have astronauts on Mars, what they got wrong, we don't know, because you never try that in reality. So probably many things can go wrong, but probably different things will go wrong that what in the films are depicting. What they got right, also we don't know, because we never visited Mars, so we don't have a human experience. We can see pictures made by robots, but we don't know what colors we are going to see on Mars, because it's not our eyes. Our cognitive system is very different from the robotic eyes. We don't know how we experience the landscape around us. So we never been put into 3D, not just the 3D virtual reality, but with the gravity, different feelings when you're there and you're in clear and present danger, always there. So no film, no movie can communicate the human feelings. That's just a story. That's, again, just the surface.
Yeah. We've actually just as we look down the list here, and I have a wonderful list of where you're all watching from and the questions that you're asking. And now I've lost what I was looking at because the list is so long. But we have had a donation, so thank you very much for the donations that are coming in. We've got donations of stars, we've got donations of money. So thank you again from Frico on Facebook. This is all helps us in keeping these programs going. I know we're running a little bit short on time, so there's a question here of we talked about we haven't had any astronauts or Mars, humans on Mars yet. Where would you recommend, now that you've mapped the planet, that would be a good place for humans to actually settle, at least initially? Is there a better place? Obviously, the equator is probably warmer.
There are some 50 special regions defined. A few years ago, NASA had this project they asked the community to suggest places, the best landing sites, and there are 50 of them. And of course, the equator is always good because it's not that cold during the winter time. But apart from that, every night is very cold. It's not very good to be in the polar regions because of the winter cold, darkness. The darkness, of course, it's not good in either planet. But underground. So if you go underground into the volcanic tubes, then it's the same, basically. If you want to see scenic views on Mars, that's probably the most dangerous places. So you have to optimize. You have to have some compromise between these nice places, and of course you have to have some available water in the form of ice in the ground. So the equator is not good for that, because in the equatorial zone the ground is dry, so you have to go up or down. Then it will be colder and darker, but you will have some water. So there's a lot of places. Of course, you want to go as close as possible to the potential life-having parts, which are defined as places where terrestrial organisms can multiply. But these are also protected by these planetary protection rules, because humans bring their own microbes. You cannot go there without your microbial system and community. So you have to send out robots to those places. Again, compromise. You land some farther away from the most exciting sites, and you have to send out robots.
Yes, because you're going to ruin the experiments you're trying to carry out in looking for life by walking all over them. So let's imagine that you are living on Mars at the moment, and I'm just flown in from Earth to visit. Now you know Mars very well because you've created the Atlas of Mars. Where would you take me? As far as tourist views, tourist spots, where would you take me on Mars to show off your planet?
If you would, what are you interested in? Of course, that's the first question.
I personally like volcanoes, but it's up to you. Where would you?
I think Elysium is a very nice spot.
Yeah.
Elysium is a volcanic rise with a lot of volcanic channels and lava flows and fossae, troughs, graben, and there are very interesting channel systems here, which are partly fluvial, partly tectonic, zigzagging channels. So that's a very exciting place because it has a very rich, colorful geography. The other one is not very far from this. And this is the youngest part of the planet in terms of volcanic lava flows and endogenic activity. So these fossae are large troughs, and there are some lava emanating from them that created islands and lava flows and lava channels and spiral forms and all these different plates, volcanic plates, platey terrain. So that's again a morphologically very interesting part. And the important thing, it's about 1 to 10 million years old, not billion like the other parts, but a few million years old. So if there is life associated with volcanism, because volcanism brings heat up from the interior, and if water was melted and hydrothermal systems created by this heat, then there might be life here around, because it's the youngest heat source on Mars.
So although we're mainly searching for fossil life at the moment with Perseverance, there may be still some survivors after all this time, which is just amazing. Yeah. A couple more questions just to wrap up. One was from a donor. So thank you very much for your donation. Methane, we've heard a little bit about methane emanating from Mars. What's the current status of this analysis?
I didn't closely follow this debate, but I think that the question is if it's biogenic or abiogenic, and almost all features and processes that suggest that had these two potential sources, biogenic, abiogenic, at the end everything is abiogenic. So it's always there is a better explanation that uses abiogenic processes.
Yeah. And wrap up, and this goes back to humans on Mars. What is, and actually I'm going to combine two questions. One is about lava tubes, which you said maybe going underground is the best way to go, because there's a question about radiation, and there is an issue with radiation for human exploration, isn't there? And maybe the answer is to get underground fast. Can you say a little bit about the radiation hazards and how lava tubes can help us in that way?
Well, the problem that Mars doesn't have a magnetosphere that we have, so the particles from both the sun and the cosmic radiation hits the ground directly. There is no ozone layer that would protect the surface from the UV radiation, and there is no magnetosphere that would protect it from charged particles. So the DNA is can be harmed by these radiation, and you cannot generate a magnetosphere on Mars artificially. So that's a question. If you may, I discussed it recently with a biologist, and another solution might be some biologic process, gene editing that creates so it improves the gene, the DNA if it's there is some problem with that. But probably the only way is using a shield, and that's the ground. The ground is a perfect shield, or a large body of water, or but there is no such water left on Mars.
Yeah. Well, we're coming to an end now. Mars is a very hostile place. It's an amazing place to explore, but no matter how dangerous it is, at least we won't get lost because we have the Atlas. So Henrik, thank you very much. We did put in the chat where you can pick up a copy of this. It's wonderful. I love flicking through it, the illustrations and the chance to explore Mars in this detail, as you say, in a tactile way, moving away from a computer screen, which is something we all need to do these days. Thank you everybody for watching. Wonderful questions. Hope you're safe wherever you are around the world, and please do join us for another SETI Live that will be happening next week. Check out our website and you'll find more details about the programming coming up. We do have an event this evening, that's this evening, West Coast California time, Drake Awards, where we offer an annual award to scientists who have contributed greatly to the science of SETI, the search for extraterrestrial intelligence. Find out more about that on our website, and there's still time to register. So Henrik, thank you very much. Wonderful to speak to you. And we will say goodbye to everybody watching. Thank you very much.